This video is taking notes on 11.6 graphing radical equations. The first thing we're going to do is look at a radical equation, which means it has a square root in it. And we have to determine what numbers we're allowed to take the square root of. If you remember, you cannot take square root of negative numbers. They become imaginary, but we are graphing real numbers. So we know that x, or whatever's inside the radical, has to be greater than 0. So if I look at this first one, x is inside the radical. So I know that x has to be greater than or equal to 0, and that's my domain. In the next one, I see that x minus 2 is has to be greater than 0. So if x minus 2 is greater than or equal to 0, if I solve it and add 2, I get x is greater than or equal to 2, and that's my domain. That means x has to start at the number 2. My next problem is y equals the square root of x minus 3. So x minus 3 has to be greater than or equal to 0. And when I solve for that by adding 3, I get that my domain is x has to be greater than or equal to 3. So I know those would be the numbers that I would start at if I were to make a graph. So let's graph this first equation. Y equals a radical x. You can see I started at 0 because if I look inside here, radical x, I know that x has to be greater than 0. So 0 is where I start. So I put in a 0. The square root of 0 is 0. Put in a 1. The square root of 1 is 1. And the next number I can take the square root of is 4. The square root of 4 is 2. And the square root of 9 is 3. So when I graph, I have 0, 0, 1, 1, 4, 2, and 9, 3. And I get a very nice little gentle curve that goes to infinity on the right and has an endpoint at 0, 0. All right, let's go down and graph the next equation. This is very similar. It's y equals the square root of x minus 2. So again, I look inside the radical. It's just the square root of x. So my domain is x is greater than or equal to 0, so I start at 0. I'm going to put 0, 1, 4, and 9 in again. And when I do that, the square root of 0 is 0, 0 minus 2 is negative 2, square root of 1 is 1, 1 minus 2 is negative 1, etc. And I do the math, and then when I graph it over here, I have 0, negative 2, 1, negative 1, 4, 0, and 9, 1. And so I have the exact same curve, but now it's displaced down 2. So if you look at the first one, it was at 0, 0, and this is at 0, negative 2. So what would the graph look like if you had y equals the square root of x plus 3? You're right, it'll start at 0, 3, and it's the same curve. All right, let's go to this next one over here. Y equals the square root of x minus 3. X minus 3 has to be greater than or equal to 0. So I know when I solve it, I get x is greater than or equal to 3. So that's my domain. So I go down here, and I know that I have to start at 3. So 3 goes in here. Square root of 3 minus 3 is 0, and square root of 0 is 0. So what number am I going to put in next? Well, I know if I put a 4 in, 4 minus 3 gives me a 1, and I can take the square root of 1, which is 1. But now I want the square root of 4. So in order to do that, I need to put a 7 in, because 7 minus 3 is 4, and the square root of 4 is 2. The next number I can take the square root of is 9. But I have to put a 12 in for x, because 12 minus 3 would be 9. Square root of 9 is 3. When I go over and graph that, I have 3, 0, 4, 1, 7, 2, etc. So the graph is shifted to the right by 3. It starts at x equals 3. Now, what would a graph look like if I wrote y equals the square root of x plus 2? Well, again, my domain is x plus 2, so x would have to be greater than or equal to negative 2. So my graph would begin at negative 2, and again, it would be the same thing, but go up to the right. All right, good luck with your graphing radical equation.